So this is the second part of this section, 1.1, dealing with horizontal and vertical translations. This is on page 8 of your unit handout. We're going to start off with just kind of more of a warm-up than anything else, because these are questions that you ought to be able to do already, the first set. So you're given, in each of these cases, a description of a transformation, and you're asked to find the values of h and k and write the equation of the transformed function. So the first function is f of x equals 1 over x, and it's translated 4 units up and 3 units to the right. And this is a problem we could have done yesterday, same with b, c, and d, but there's something I want to talk about with regards to this. So let's identify what h and k are to begin with. If it's translated 3 units to the left, then h must have a value of -3, right? Left is horizontal, left is a negative, -3 is h. If it's translated 4 units up, then that means that k is equal to +4. And I'll maybe make a point of really saying +4. It's equal to 4. We don't need to write positive, but since up is a positive direction, I'm really driving that point home. So what that means is that based on our template, what comes out of this is y equals, well, I'll use g of x, I guess. G of x will be equal to f of x minus h plus k. That's the template. That's what you have to remember. And that means that the new function's equation will be g of x equals f of x plus 3 plus 4. And I hope that we are all in agreement on that. Okay. But see, and here's the thing, though. That is correct, but there's a better answer. And the reason why there's a better answer for the equation of g of x is we know what f is in this case. We had a little conversation right at the beginning of class, Georgia and I, about the fact that you can't, for many of these problems, check to see if your point is in the right location because you don't actually know the function. It's just some function, like everything on your quiz was. You couldn't put stuff in your graphing calculator. But here in this question, we do in fact know, we do in fact know the equation of the function is f of x equals 1 over x. So remember what that means. If f of x is 1 over x, and I want to just write it down, I can probably squeeze it in on a full screen, sure. If f of x is 1 over x, then f of, say, 4 is 1 over 4. F of monkey is 1 over monkey. So this part, f of x plus 3, this part will be 1 over x plus 3. This is simply saying where there's an x in the original function, put in the x minus h, which is x plus 3. So our function now, this, g of x, if we follow this along, it's f of x plus 3, which is 1 over x plus 3, and then plus k is done afterwards, right? I called it yesterday kind of an afterthought. And I would hope that, so this is our answer. I would hope that many of you would be able to look at the description of the transformation, look at the equation of the function, and come up with what our answer is without necessarily doing everything that's on the right-hand side of the screen. Although if this is any kind of written response, you need to justify things. Okay? So this isn't really new. It's a different function. We didn't look at 1 over x yesterday. But in this case, you could, in fact, graph this on a graphing calculator, graph g of x on a graphing calculator, and see if it's shifted the correct amounts and in the correct directions. And it would be. And this is going to be a little repetitive, and this should be fairly easy, this first set of examples, but there's a point that I want to make at the end. So the function f of x equals the absolute value of x is translated 5 units up and 2 units right, which means that h is equal to +2 and k is equal to +5. Just mull that over in your brain and see if you agree with me on that. I hope you do. Okay. that means that the equation of the new function g of x is f of, I'm not going to write f of x minus h plus k. We know that that's what it is. I'm just going to start using it. F of x minus h plus k. So that, again, I'm trying to reinforce to you what this f of means. That's the functional part of what we've written here. This part right here depends on what f of x is. And then afterwards, to get the new function completed, we add k. And I should have put plus 5. After I said I'm not going to write f of x minus h plus k, I ended up writing plus k, but it's plus 5. So what is f of x minus 2? Well, it's the absolute value of x minus 2. Because, and I want to be clear here, we're not done. This is just that. Right? I still need to add the k, so then I need to go plus 5. And, you know, I think many of you, now looking at this answer, this is where you check, I think, that you look at the x minus 2 and you go, oh, well, that means it shifted 2 to the right. You look at the plus 5, and that means it shifted 5 up. And then you can look up and go, oh, yeah, it was 5 up and 2 to the right. Are you with me on this? F of x equals x cubed, and it's translated 6 units down and 1 unit to the left. See, this is what I'm talking about. I think, even though we are asked to find h and k, you ought to be able to see that the function will be this. So, and what's happening here, I think, is your brain is taking what you learned about x squared and x minus p quantity squared plus q. You're taking that, and you're just being adaptable now, and you're saying it's x minus h instead of x minus p, and it can be in any function. It can be in any function. It doesn't have to be x squared. And what it means is that every x in the function becomes x minus h, and then at the end you add k. But if you want to formalize this, of course, you would look at this and you would say, well, k is negative 6, h is negative 1, so you would write g of x equals f of, and again, watch what I'm writing as I'm saying it, f of x minus negative 1, and then minus 6 because it's plus k. And then you would say, what does f of x plus 1 mean? It means I go up to the original function and put x plus 1 every place there's an x. Are we good with this one? Okay. And finally, f of x equals root x. So the function is the square root. It's translated 8 down and 2 to the right, which means h is equal to positive 2 because 2 to the right is a positive horizontal. K is negative because downward is negative, and it's negative 8, which means the new function is g of x equals f of x minus 2 plus negative 8, which is minus 8. And once again, what does f of x minus 2 mean? It means you're going to go to the original function, and wherever there's an x, you're going to put in x minus 2. Because if f of x is root x, then f of 5 is root 5, and f of pi is root pi. So f of x minus 2 is root x minus 2. So we get the following. And I always, when I do these, it's a simple set of rules, but as I said yesterday, you're walking along and you'll stumble from time to time. You'll trip. So I always like to look at the final result and go, what is this saying to me? It's saying 2 to the right and 8 down. I look up and it looks good. So we're okay with that? So here's the thing I want to add that I think is important. And it never occurred to me until a student asked me this question a very long time ago, maybe 15 years ago. They said, good student, smart student. She said, you're missing something. Let's go to, say, let's go to this one. and I don't know if it was this exact question, but she said, you're missing something. I'm sorry, but you've made a mistake. And I make mistakes. So I welcome corrections. And I looked at the screen and I said, 6 down, 1 to the left. I think that's right. And she said, no, you forgot the cubed. I said, where? What do you mean? Here. You forgot to put cubed. And that's an interesting question, isn't it, that she's asking. I didn't forget to put cubed. I don't put cubed. And the question that I have for you now, and it's the question that I asked the whole class, is no, I don't put cubed there. Who can tell me why I don't put cubed there? Oh, that's exactly right. But next time, don't just put up your hand or give people a chance to think, please. That's exactly right, because f is cubed in this example. And this is a serious algebraic mistake that if you were writing a written response, sometimes people will write this, which is absolutely incorrect. That's not it. It's just f of x minus 2. So in all of these, and Eric nailed it, in all of these, your f has a very specific meaning. The f here is 1 over. So we don't put f of 1 over x plus 3. 1 over x plus 3 is f of x plus 3. In this question, the f, I'm going to get rid of this just so you can see it. The f in this question is that. It's, the function is the operation. In this question, the f is cubing. So when I say x plus 1 cubed in this question, that's the same as saying f of x plus 1. In this particular case, and I think you're catching my drift, the f is a function that's saying square root the input. So when the input is x, it's root x. When the input is x minus 2, it's root x minus 2. Okay. All right, let's move on. We only have 2 other examples today, but I want to spend some time talking about them because it turns out that to solve each of these questions requires the same general strategy. And I use this in Math 20-1, and if I didn't have you for 20-1, this might be new. And this strategy works because we think of h and k as being what are called parameters. The parameters are numbers in a function that determine the function. Okay? And I don't want you to get ahead of me on this question, please. So, for example, if you go back to Math 20-1, and I give you y equals x minus p quantity squared plus q, y and x are variables. They're numbered, when we look at this whole relation or this whole function, they're numbers that occur in ordered pairs, and there's an infinite number of pairs of numbers for x and y. But each individual quadratic function has a unique value for p and q. P and q are called parameters that define the function. Okay? They're not variables, they're parameters. They're numbers. Okay? So h and k are parameters, and I've already used that word. So what does this question say? It says we have a function, and we can write f of x equals x squared if you like. It doesn't matter. Y equals x squared, and we're going to transform it vertically, translate it vertically, and the resulting function has to pass through 5, 12. What's the amount of the vertical translation? And what you do not want to do at this level is approach this type of problem as a puzzle. Because if you don't have a unique strategy that's going to always work, your puzzle rules are going to be different every time you see a different question. But if you have a strategy based on a set of rules, it will work for everything. So the idea here is that if it says there's a vertical translation, and it says what's the vertical translation, then what we have as a task is to find k. And I called this, we did this, and I don't know if anybody will remember from Math 20-1. I'll tell you when it happens in Math 20-1, and some of you might remember. It happens where we have something like this, except we also had, I hope you remember there was this a, right? And I tell you that a parabola has a vertex at 2, 6, and it passes through give me 1 second. Three, 9. What's the equation of the parabola? So let's do this problem. You don't need to write it down, but I want to do this with you. If you want the equation of the parabola, you need to know the values of these 3 parameters. That's it. That's your goal. And you know P is 2 and Q is 6. You could even call it H and K if you like, and I hope you understand what I'm talking about here. That this is 2 and this is 6. So does anybody from my Math 20 class remember what I called this thing? It's a missing parameter. And I'm a firm believer, if you remember that phrase, missing parameter, that will lead you to the approach that we always use to find a missing parameter. Whether it's in Math 20 or Math 30 in this unit, or in trigonometry, or in exponential and logarithmic functions, or wherever. Lucas, do you remember how we find a missing parameter?
You input the x and y values that it passes through into the equation.
Perfect. So what we do is we build the equation as well as we can with these parameters. We would say y is equal to a times x minus 2 quantity squared plus 6. And to find the value of a missing parameter, we need to load in an ordered pair, which is a point the graph passes through. The reason why this graph passes through 3, 9 is because when x is 3, y is 9. Think about that. When x is 3, y is 9. Well, let's use that idea. And you might remember that I always like to put a little table of values here to reinforce the fact that it's a point. It's one of a gajillion points. But what it means is that when you put x equals 3 in, you will get y equals 9. And that's a way that you can find the value of a. And like I said to my Math 20s yesterday, this takes all the thinking out of it at this point, because it's just math. I just have to follow the rules of math. I don't care what got me here. I simplify this and I get a 9 equals a plus 6. 3 minus 2 is 1. 1 squared is 1. So I get 1a. A is equal to 3. 9 minus 6. So the function is 3 times x minus 2 quantity squared plus 6. It's a missing parameter. So let's go back and let's use this idea here. What vertical translation is applied to y equals x squared if the transform function passes through 5, 12? Well, if there's a vertical translation, and it doesn't mention horizontal, so we assume there isn't one, then the new function is g of x equals f of x plus k, because h doesn't play a role here. Which means, everybody, and I'm not so sure you needed to use function notation here, that if I take y equals x squared and I translate it vertically, the new equation is x squared plus k. Right? And in fact, this is a case, everybody, where I think what I'm about to write is easier on the brain in this application. Let's just talk about y equals x squared plus k. I hope you understand this y that I'm pointing at here at the bottom of the screen is a different y than the y at the top of the screen in y equals x squared. So we could use f of x and g of x, but I'm not. So how do we find k, which is the answer to the question? We say to ourselves that since the graph passes through 5, 12, 5 for x and 12 for y are inextricably tied together in this function. When x is 5, y is 12. That's a fact. So that means that when I put in 5 for x, I have to get 12 for y. And then this is, as I like to say, like taking candy from a weak, tired baby. You just go over, and if the baby puts up any fight, you just push it out of the way and you grab it. It's easy, okay? Don't do that. Mr. Way's School of Babysitting. 12, I square 5, I get 25. So I have 12 equals 25 plus k. I guess I'm going to have to subtract 25 from 12. 12 minus 25 is, I believe, negative 13. Good. So k is negative 13. And here's an example, Georgia, because you had asked about this. Here's an example where we can actually test this out on our calculator. Okay. Except my calculator's not here. I guess I should answer the question. The answer to the question is the original function has been translated 13 units down. And I've already got something on this calculator. I want to get a new one. There we go. So we can graph y equals x squared. Don't ask why, but that's how I choose to enter x squared. And we can graph y equals x squared minus 13. I'm also going to put in the point 5, 12, so you can see it. Don't worry about if you remember how to do this or not. If you go to Stat and then Edit, you can enter in 5 for x, 12 for y, and you have to turn on a stat plot to see it. I also have to adjust my window setting. I'll go zoom standard first, which takes me from negative 10 to 10 in both directions. I want to see 5, 12. So 5, 12, I need to look up higher. I'm going to go to my window setting and manually change the maximum y to 18. Graph. There's x squared. There's our transformed function, and it's passing through 5, 12. Does anybody have any questions with that example? Okay. It's a really important idea, this missing parameter thing. And it's the phrase. The phrase missing parameter should start to trigger into your head, oh, I got to load in an ordered pair. Let's take a look at the next one. We're going to take y equals x squared, the same function we had to begin with, and we want to transform it horizontally this time so it passes through 10, 9. Well, the new function, and I'm going to forego the function notation here, the new function, the one that's going to pass through 10, 9, will be y equals x minus h quantity squared, because we've applied a horizontal translation to x squared. And this function needs to pass through, so I'm going to say the new function contains the point 10, 9. What does that mean? Again, I like the table of values approach here. Sometimes students really need to see, I think, that these are connected, because the input of x equals 10 gives you an output of y equals 9. I know that 10, 9 is telling you the same thing, but for some reason, if it's in a table, it might be more helpful. That means I have 9 equals x minus 10, pardon me, 10 minus h quantity squared. And I have to solve that equation, which is not a difficult equation to solve. I'm going to solve it, and somewhere along the way I'm going to make a mistake. I'm not predicting that, no, I'll probably make a mistake. That's not what I'm saying. I'm intentionally going to make a mistake. Okay? I'm not going to tell you where. So I'm going to take the square root of both sides to get rid of that squared. There are some of you I have never taught math to before. And this linear equation that I have, the unknown is negative, and I just always prefer to have the unknowns being positive. So I just move it to the other side. I don't go plus h at this level. So h, and then I have 10, and I subtract 3, and I get h equals 7. So the horizontal translation, according to my work, is 7 units to the right. And that's wrong. The question is, does anybody know what I've done wrong? And the hint I will give you is, it's wrong if it's an incomplete solution. Okay? This may be a correct statement that if I translate it 7 to the right, it will pass through 10, 9. But as an answer in mathematics, it's wrong. Lucas, do you know? What have I done wrong?
You can't just move the square over onto the other side and leave it off the 9.
So in which line is there an error?
From 2 to 3.
Why not?
Because you're supposed to double dip and do that.
Supposed to what? A little louder?
Double dip or whatever you want to call it. You have to do 2 sets of brackets and do that.
Oh, double dip. I like that. So let's look at what happens. What Lucas is recognizing is this is a quadratic equation that should have 2 solutions, right? So what you're saying, I think, is that the proper way to solve this is to FOIL out 10 minus h quantity squared, which actually means that. Now, you don't have to write this, but you do have to know that 10 minus h quantity squared means 10 minus h times 10 minus h. So we expand this out, we get 100 minus 10h minus 10h plus h squared. We're just using FOIL from grade 8 or 9, whenever you learn it. 10 times 10, 10 times negative h. You say to yourself, so the difference between what I did here and what we're supposed to do is the difference between Math 10 and Math 20. In Math 20, you learn that if it's quadratic, you have special ways to solve these. You zero the equation, always zero the equation. Well, maybe not always. But in this case, I'm going to zero the equation to get h squared minus 20h. And then I have 100, and I have to subtract 9 to get it to be 0, which I believe is 91. And then your first, am I right? Rearranged okay? Okay. Your first line of attack is always to see if you can factor it. Now, I always have this shortish lesson. This is the final example, because there are some things I want to review from previous math. Okay? So, if this is factorable, there are 2 numbers that multiply to give 91 and add to give negative 20. And if you're like me, I know what the answer is. So I know what the numbers are. But if you're like me and I looked at this out of the blue, I wouldn't know if those numbers exist. So does anybody remember from Math 20 how you can tell for sure if something's factorable? Do you remember?
Isn't that like an equation of like b squared minus 4ac?
Exactly. And if b squared minus 4ac is a perfect square, it's factorable. So the reason why I think that's important, is that the factoring we do at this level is always kind of a trial and error thing. And there's nothing more frustrating than sitting there trying different combinations for factors if it's not factorable. So let's calculate, all of us please, b squared minus 4ac. b is negative 20. Of course, you're going to square that, so the negative will go away. And then minus 4 times a is 1 times c is 91. I couldn't tell you what you get. There's no way I can do that. Well, maybe. 36. I got it. It's 36. So this works out to 36, which is a perfect square, and that tells me now it's factorable. So I know I'm not wasting my time at this point. And, you know, you think about this. Let me ask you a question here. How many of you might, in a situation like this, go, I couldn't be bothered to find the numbers, I'll just use the quadratic formula? Maybe. It turns out it's 7 and 13, isn't it? Well, negative 7 and negative 13. Check it out on your calculator. Negative 7 times negative 13 is positive 91. So then what you do, and again, I'm taking the opportunity to review some fundamental ideas that are really crucial at this level. Then what you do is you say, if the product of two factors is equal to 0, then that tells me that either one of them being equal to 0 will make the whole thing 0. And this is where we get the two solutions of 7, h equals 7, and h equals 13. So I want to come back to this, because this is wrong on the left, but it can be fixed. Okay? And I'll get to that in a second. So the answer to the question is 7 units right or 13 units right. The math doesn't lie. The algebra doesn't lie here. If you follow the rules of mathematics, you get answers that are correct. Sometimes those answers need to be compared to the original question to make sure they're valid. For example, if the original question said y equals x squared is shifted less than 10 units and it passes through that point, how far is it shifted? The answer would be 7. Okay? But with no restrictions, that's the case. I want to show this to you now and then correct the mistake that's been made up here. So what I have on my graph preloaded is y equals x squared, and is it 10 comma 9? Is that what it is? Okay. Yes? Okay. So I have y equals x squared and then 10 comma 9. I also have loaded in here x minus 7 quantity squared, which would be 7 to the right, and x minus 13 quantity squared. I don't know if you know this. They're not appearing as graphs. That's because I've turned them off. If you put your cursor over the equal sign and hit enter, then the equal sign is no longer highlighted and it won't graph it. So sometimes if you have multiple graphs and you just want to see one or two, you can turn the others off. I'm going to turn on the x minus 7. Quantity squared, and it passes through that point. So how can we get a second answer? The answer is we can take this graph and we can shift it even further, so it will be the left arm of the parabola that's going to pass through that point, 10 comma 9. And it turns out that that extra distance happens to be 6. I have to go 6 more units. That passes through there. All right, before we get to work on your practice today, and you will have lots of time, there is something I could have done to correct things. This is right, this is right, this is right, this is wrong. But there's something I can include in this line that I've written to make it correct. Hunter? Plus or minus. And this is the thing you learn in Math 20. When you solve quadratics and you take the square root, well, no, forget about quadratics. Whenever you introduce the square root, you have to go plus or minus. And the classic example I would give you, this is now correct, is if I say to you, okay, everybody, what is the solution to this? And everybody goes 3. And I go, no, it's not 3. It's plus or minus 3. Because 3 squared gives you 9, and negative 3 quantity squared gives you 9. So when you do this, that's your responsibility. Now, had I done that, then it would be correct. And what would happen at this point is this means two equations. It means positive 3 equals 10 minus h, or negative 3 equals 10 minus h. If you solve this equation, I don't like doing that. If you solve this equation for h, you get h equals 10 minus 3. If you solve this equation for h, you get h equals 10 plus 3. And you have your two solutions. Although this method on the left, it's not always available because it's not always something squared equals something. But if it is available, I still don't like it. I would rather expand things out and factor or use the quadratic formula or some other method. Okay? Okay, so your assignment then is